Hello everyone. So now we'll see about the Pinkoff Treadwell method. So the titration cell consists of two electrodes. The indicator electrode is placed in the solution which is to be titrated. And the reference electrode is placed in the solution whose composition or potential is equal to the indicator electrode potential at the end point. So such type of electrode combination has zero potential at the end point, which is signified by the null deflection in the galvanometer. So we are using we are using two electrodes. The titration cell consists of two electrodes. Here you can see the first one is indicator electrode, which is placed in the solution, which to be titrated, and second electrode is reference electrode, which is placed in the solution which composition or potential is equal to the indicator electrode potential at the end point. So this is how we can measure this ping-pong Treadwell method. After that, we have a direct titration to the equivalent point. Here this method is applicable only when the equivalent point is known by the theoretical considerations or by the previous titrations. So the additional advantage of this method is that no titration data need to be recorded, and the titrant is slowly introduced near the equivalence point until the potential of the indicator electrode as measured with an appropriate instrument attains the desired value. And the last one is a Grant's procedure. It is a simple method for fixing an endpoint. If a series of addition of reagent are made in a potentiometric titration, the EMF is noted after each addition, and then anti-log, that is E equal to ANF by 2.303 RT, is plotted against the volume of reagent added, and a straight line is obtained. So when the extrapolated, this line cuts the volume of axis at a point corresponding to the equivalence point volume of the reagent. So plotting is simplified if the spatial the plotting is simplified if the spatial semi-antilog Grant's plot paper is used. The advantage of this method is that the titration need not to be pursued to the equivalent point, and it is not only necessary to have the requisite number of observations before the endpoint. So also we will see some type of potentiometric titrations. These potentiometric titrations may be applied to a variety of systems, including those involving oxidation reduction, neutralizing precipitation, and complexometric equilibration. So types of potentiometric titration, here you can see some that we have redox titration, neutralization titration, precipitation titration, complexometric titration, potentiometric titration in non-aqueous solvents, acid-base, differential, and automatic titration. So first one we have this acid-base titration. So it is done in aqueous as well as non-aqueous medium, and the indicator electrode is used in a glass electrode, and the reference electrode is saturated calomel electrode. So all this acid-base combination of any strength and a mixture of acids or bases versus bases or acids respectively, and polybasic acids versus bases can be analyzed. In non-aqueous medium, same electrode used, weak acids versus methoxides, and weak bases versus phosphoric acid. Thank you.